So we've been looking at redox, and that involves the oxidation and reduction, which is loss and gain of electrons. So far we've been able to identify things as being oxidized or reduced by seeing electrons in an equation or a half equation, or noticing that their charge has changed. But we can't always do that because not everything has a charge. What we can do, however, is assign what's called an oxidation number, which is like a theoretical charge, so we can then start to see where this charge or where these electrons are moving from and to. So these are the rules that govern oxidation numbers. Elements have no charge, so we give it an oxidation number of 0. Ions already have a charge, so they get their ionic state as their oxidation number. Oxygen gets a number of -2. So every oxygen that you see has an oxidation number of -2. Hydrogen always has an oxidation number of +1. Now there's some exceptions to those last two rules, but I'm not going to talk about those in this video. Once we understand and assign these rules, we can then add to get an overall charge of what the species is. Now this isn't making a lot of sense now, but let's just put this into action and find out how we can assign oxidation numbers. So let's assign these oxidation numbers. Firstly, oxygen, that's -2. So each oxygen is -2. I've got 2 oxygens, so overall, oxidation-wise, this means -4 because I've got 2 lots of -2. Now we need to add up to make this the charge of the species. Carbon dioxide has no charge whatsoever. What that means is this carbon must be +4. The carbon's oxidation number is +4. The oxygen's oxidation number is -2. Let's look at ethene here. Each hydrogen by default is +1. What that means, overall, our hydrogens have an overall theoretical charge oxidation number of +6. What that means, these 2 carbons must be able to balance out our 6 to make the overall charge of 0 here. This guy has no charge. What that means is that these carbons must be -6 altogether. That means each carbon must be -3. So therefore, the oxidation number on the carbon here is -3. The oxidation number on our hydrogen is +1. Let's look at the last one here, which is the carbonate ion. By default, our oxygen is -2. What that means is overall, from our oxygens, it's going to be -6. Okay, now here's where it gets a bit funny because we've got a charge. What we need to do is add all these oxidation numbers up and they have to get to -2. So what do I need to add to -6 to bring it up to -2? That's going to be +4. So therefore our oxidation number on carbon in our carbonate is +4 because +4 take away 6 gives me -2. And that's assigning oxidation numbers to these guys.